Welcome to my channel, guys. Today we will be solving JEE main PYQs. जैसा कि आपको पता है कि NTA ने आप लोगों के साथ गेम खेल दिया है, तो ख़त्म आपको करनी है। एंड फॉर दैट जब भी रीनीट हुआ है, पेपर टफ आया है, तो जस्ट टू प्रिपेयर यू फॉर योर फिजिक्स पार्ट इन द अपकमिंग रीनीट, आई हैव प्रिपेयर्ड दिस वीडियो ताकि आप लोग थिंकिंग सीख पाए, कैसे प्रॉब्लम्स को हैंडल करनी है अगर आपको दिक्कत आए। सो लेट्स कंटिन्यू। जस्ट फॉर माय क्रेडिबिलिटी, I have cleared advance. I study in NIT and I'm also a student like you. So मुझे पता है आपको कहाँ दिक्कत आ सकती है, कहाँ आ रही है. So let's just expand our domains and start simplifying physics for you. I'll be using both Hindi and English for our videos, and please excuse the background noise, just bear with it. And whenever you have this kind of problems, you just take R as constant. What we can do is P equal to V square upon R, right? So R is constant, so we can do V1 proportional to V1 square and P2 proportional to V2 square, right? So we can do P1 upon P2 equal to V1 square upon V2 square, right? So we have 100 upon P2 equal to 220 into 220 upon 110 into 110. So we have 4 here. So P2 will be 25. Simple enough. ऐसा नहीं करना है कि हमें इन दोनों से R निकालना है, फिर R को इस पर डालना है, फिर हमें P निकालना है, ऐसा नहीं है. Simply do it like this. Next what we have? We have here the parallel combination. यहाँ बस आपको ये फॉर्मूले याद रखना है. E effective as R effective as summation over I EI by RI, right? So first we find R effective. For R effective, we have two. We have a 12-volt cell with 2 ohm and an 8-volt cell with 1 ohm. Simple. So we do 2 times 1 by 2 plus 1. That's 2 by 3. So we have this option and this option. And for E effective by R effective, we have 12 by 2 plus 8 by 1. We have 14 here. Let's multiply. And हमें मिल रहा है 28 upon 3. So first option. You should remember this formula. ये concept किसी और जगह भी यूज हो सकता है. You can just remember this. Wire stretching. So what we have here as rho L upon A. If we increase the length from 2 to 10, right? We have 2-meter wire with 10 ohm. It is stretched uniformly though. So we have stretched it 5 times. But the volume remains constant, right? So if we do it like this, so it has to decrease, right? So area becomes A upon 5. 5 goes up. So we have 25 R. Simple. R was 10. So it will be 250 now. Just takes 5 seconds to answer the question. Moving on to the galvanometer. ये आपके 26 में भी आ चुका है. And see, this is why you should be doing JEE main questions. This is why. So what can we do? We can just take the galvanometer and shunt it to make it an ammeter, right? We have the current coming in as 1 ampere, sorry, 10 ampere, right? गैल्वेनोमीटर को जो हम शंट करते हैं, we take the current, let's say this is I, this is IG, right? And this stuff is I minus IG, right? We take the current going into the galvanometer as very small, and then we take this I, that current going into the shunt, as I minus IG, right? Like 10 minus IG. IG is 1 milliampere, right? So we just take it as 10. We don't consider this. So we can do matching of potentials across this galvanometer, across the shunt. What we can do is take the shunt into the shunt current. Shunt current is 10 ampere, right? 10 ampere. And galvanometer is 100 ohms. And the current across it is 1 upon 1000 amperes, right? So what we have here? We have the shunt as 10 upon 1000, 1 upon 100, that is 0.01, first option. You just need to know this thing. This thing is important. That IS will be 10. We don't calculate this stuff. 10 minus 0.001. We don't calculate this. Next, we have temperature. Simple enough. You just need to know the formula. We have 50 ohms at 27, and we have alpha as 2.4 into 10 power minus 4 per degree centigrade. We need to find the temperature at which it becomes 62 ohms. Formula here is R dashed, the new one, as R times 1 plus alpha times delta T. So we have 62 equals 50 times 1 plus. We have been given the alpha, so we have delta T. We don't know it. यहाँ आपको क्या करना है कि 50 को यहाँ पे लेके आना है, ये हो गया 12, ठीक, and 5 times 25, right, 120. Take the 0 and move the decimal, and 10 power minus 4 into delta T. So we have delta T as what we have. See, we have 10 power minus 4 here and 0. So 10 power minus 3. And here it is just 10 power 0, right? So we have 10 power 3 here, naturally. This is 10 power 0. And this stuff needs to be. If we take this out, we have it minus 3. So we need to have 10 power 3, right? So it is just 1000. We just need to add it, so it becomes 1027. Option number A. So next question, power dissipation. Power is PI or is equal to R. We have a battery 20 or 2 ohms. एक्सटर्नल सर्किट 3 और 6 पैरेलल में है. हमें निकालना है पावर इन द इंटरनल रेजिस्टेंस ऑफ द बैटरी. So we have 20 volts with 2 ohms, and we have 3 3 and 6 in parallel. Whenever you see 3 and 6 in parallel, you should remember this. I think it is 2. So this thing is 2, right? This thing is 2. This thing is 2. So 10 volt across this, 10 volt across this. हमें पावर यहाँ पे चाहिए 2 पे. So we know the voltage, we know the resistance. So पावर क्या हो जाएगा? 100 by R is 2. So option number 8. You should be done with these questions under a minute. Okay. So यहाँ पे क्या है? मीटर ब्रिज. मीटर ब्रिज में बोला गया है कि लेफ्ट में 10 ओम है, जॉकी का पोजीशन 40 पे है, from left, and then we shunt it with a 10 ohm. Okay, so now we need to find the new balance. Okay, we just draw the diagram. 10 ohm in the left gap. We don't know what is at right gap. We just know this is the meter bridge, right? And we have the jockey at 40, right? So this will be 60, right? Whenever you have meter bridge questions, just take the resistance as 1 ohm per centimeter. This 100 centimeter, as you know. So हमें क्या करना है अभी कि Wheatstone bridge, right? This is a galvanometer. यहाँ हमें क्या करना है? 40 ohm, simple, times R as 60 times 10, right? But we have R as 15, right? R as 15. हमें पता चल गया कि ये 15 है, ठीक. अब हमने क्या किया कि इसको हमने शंट कर दिया विद द 10 ओम. अब जो R न्यू हो गया वो क्या हो गया? 15 इंटू 10 25, ये हो गया 3. This is 5. So what we have? 6. So now the jockey will have to change the position, right? हम मान लेते हैं कि लेफ्ट से जो लेंथ होगा, लेफ्ट से जो वो L है, इधर से हो जाएगा 100 माइनस है, ठीक. तो फिर और यहाँ पे लेफ्ट पे तो सेम होगा 10, राइट पे हमने पता कर लिया कि ये 6 होगा, ठीक. जस्ट मल्टीप्लाई, क्रॉस मल्टीप्लाई, सिंपल. 10 into 100 minus m equals 6 times m, right? So हमें मिल रहा है कि 16L is 1000. L will be 250 upon 4. That is 62.5. As you can see, it is not divisible. So there is only one option here, which is not divisible. Drift velocity, the easiest question, I think. You see the current is steady, right? Current is steady. We have area at a point as this and velocity this. At this point, area is this. We need to find the velocity, right? So the current is NEAV, right? We have N same, E same. एरिया बदला हुआ है तो फिर वेलोसिटी बदल जाएगा. current remains same, right? I1 equals N or E constant. Just equate them. Just we have 2 into 10 power minus 6 into 2 10 power minus 4 equals 10 power minus 6. We have, we have 4 10 power minus 4. The easiest question there is. Next, we have a question from 26 of means. We have a point here as A and a point here as B. We need to find the heat in a minute, that is 60 seconds. Battery is of 9 volts and we have 1 ohm. यहाँ देखिए कि आपको 1 ohm बोल दिया गया है बट डायग्राम में नहीं दिया गया है. So you should write. And we need the heat. So what is heat? Heat is I square RT, right? So we have T. We need R and we need I. For RAB, this is a bridge, right? This is a bridge. So you neglect this. And what we have here? We have 3 in the upper arm, 3 as you can see. And we have 6 in the lower arm, 6. So what we have? Parallel of 3 and 6. I told you already. It's a common thing. This is 2. So we know R, we know T. We just need the I, right? For I, what we have? We have RAB here. We have another 1 ohm here. So the resistance will be 9 volts. 2 plus 1, right? So it will be 3 amperes, right? So what do we have? The heat to be? Heat to be I squared. I squared RT. We have R as 2 and T as 60, right? So we have 18 times 60, that is 1080. यहाँ बस आपको ये पता होना चाहिए, बस और कुछ नहीं. क्वेश्चन आपको ये ब्रिज दिखना चाहिए कि ये ब्रिज है, ये आपको दिख ही जाएगा कि ये ब्रिज है. Next we have from 25 of means and यहाँ पे 2 cells है with 2 ohm and 1 ohm connected in series with 6 ohm. Okay, we have the current. And then we have the same 2 cells connected in parallel with the same resistance. See, that formula is working here. So we have I2 here and हमें ये रेशियो चाहिए. आपको देख के पता चलना चाहिए कि इस क्वेश्चन में आपको टाइम लगेगा, तो ये बाद में करना है आपको. ये छोड़ के चले जाना है, फिर वापस आना है इस पर. So we have a cell 1 volt with 2 ohms and we have another cell of 2 ohm with 1 ohm and we have external of 6 ohms, right? We see the current here to be 3 volt upon, there is 3 and 6 is 9, 1.3, right? 1.3 amperes. नेक्स्ट क्या करना है कि आपको इन दोनों को लगाना है पैरेलल. ठीक है, और यहाँ पे ये हो गया 6 volts. This is 1 volts. This is 2 volts. This is 2 volt and 1 volt. You see, Goj is also making fun of us. We are struggling here a bit. So, what do we have? We need the current, right? We need the current. For current, we need we can just replace this whole thing, you know, with a EMF and a resistor, right? So we can just replace it. Simple. Or we can try something. Let's see. If we take 0 volt here, okay, what will we have? We can have 1 volt here and 2 volt here. And we take the potential here to the extent. We take the potential x2 here. So what will be the current in this branch? Current in this branch will be 1 minus x upon 2. In this branch, it will be 2 minus x upon 1, right? So if you add these two currents should be equal to, if we take the current direction to be this way, it's flowing this way, right? It should flow this way. It should be equal to x minus 0 upon 6, right? This way. Okay. So we can have what? We can just add these two, right? If we add this two, then 1 minus x plus 4 minus 2x upon 2 will be equal to x upon 6, right? So we have 3 here, and x will be 3 times, that is 5 minus 3x, right? So we have 10x as 15. So we have x as 3 upon 2, right? We needed the current, right? You remember, we needed the current. For the current, you have potential here, you have potential here. So you just need the current. So what will be current? It will be 3 upon 2 upon 6. That is 1 upon 4, right? So the current, so this current, I2 here is 1 upon 4. And we had I1 here as 1 upon 3, right? 1 upon 3. We need I1 upon I2. So I1 upon I2 will be 1 upon 3 by 1 upon 4, right? That is 4 upon 3. So we have x as 4. It took some time. You can try this method, this method, or you have to calculate, you know, the equivalent EMFs and equivalent, you know, resistance. It will take some time, but I think this method will work. It will take some time, but it was a good question. And we have another ammeter. So we have 150.4 here. We have 240 here, We have a shunt here. We need the reading of the ammeter, right? What we have here, the parallel, the combo of these two. We have 240 times 10 by 250, right? Okay. What we have here? We have 5 here and we have 4, 8, right? So we have 9.68. So the R total, including this, it will be 150.4 plus this guy, that is 168. So we have the total current, right? This is total current. It is 1 upon 8, right? 1 upon 8. We need the current in the ammeter, right? In the ammeter. So the current will be 1 upon 8 into, you see, V equal to IR, right? So I is inversely proportional to R. So the current here flowing through here will be inversely proportional to the resistance, right? That will be 10 by 10 plus 240, right? That is 1 by 8 into 10 by 240, right? What's that? ये एम्पियर में, तो इसको हम लोग मिली में कन्वर्ट कर लेंगे। तो क्या हो गया, ये हो गया 4, ये हो गया 2, ये हो गया 5 milliamps. This is it. Next we have, I think this won't be here. This won't be here. Just excuse this. We have, what we have here? Designed to operate at 1000, you see, with a 100-volt line. Okay. So we have its resistance connected in a combination with a resistance of 10. We have 10 here. And this is our 100-volt means. Okay. Heated to operate at 62.5. Okay, so the power across this will be this one. So we need the value of R. Okay. So what we have, so we have the heater's resistance. You can just use proportionality, right? And just use proportionality as P1 by V1 square. P1 square upon square, right? So यहाँ पे P1 क्या है? P1 है 1000, right? By P2. P2 हो गया है 62.4 ये है v1 स्क्वायर। v1 कितना है? v1 है 100। 100 स्क्वायर बाई v2 स्क्वायर। ये हो गया 3 0 गए, 3 0 गए, ये हो गया 625। v2 स्क्वायर 625 हो गया। v2 कितना हो गया? 25 volts. So we should be having 25 volts across this, right? So if you are having 25 volts across this, then what should you be having? P equals IR, right? So across this combination, you should be having 25 volts. So for the value of R, so for the value of R, we will require, I think, the resistance also of the heater. So R is P equals V square upon R. R is V square upon P. Okay, R is V squared. V squared upon P. R is 10 ohm, right? 10. ये है 10 ohm का, ये है R का, ये भी है 10 का। तो फिर हमें चाहिए वोल्टेज, so we need R, right? So we will take RBC. We will be taking RBC. And for taking RBC, and then we have 10 here. So RBC will be we have 100. We have the current as same. So V proportional to R, right? 100 into RBC by RBC plus 10 will be 25. So what we have here? We have RBC plus 10. We have 4 here as 4 RBC, right? So we have RBC as 10 by 3. So we have 10 into R by 10 plus R as 10 by 3. So we have 3R as 10 plus R. So we have 2R as 10. So we have R as 5. This should not have taken this long to solve, I think. I think if you know the, if you process it a bit fast, I think you can do it, but it is a lengthy question though. नेक्स्ट हमारे पास है क्यू प्रॉब्लम। यहाँ एक बैटरी है 6 वोल्ट की। हमें यहाँ पे निकालना है पोटेंशियल अक्रॉस ईएफ, ठीक है। तो हम यहाँ पे क्या करेंगे कि हमारे पास इस लाइन के अक्रॉस सिमेट्री है, ठीक है। तो फिर जब भी आपको सिमेट्री दिखे तो आपको पॉइंट निकालनी है कपल में, पी और डी दोनों सिमेट्रिक है अबाउट दिस एक्सिस ई एंड जी। तो इन दोनों का पोटेंशियल जो है वो सेम होगा। तो फिर हम सर्किट को रीड्रॉ करेंगे। लाइक यहाँ पे हम ए मान लेते हैं, यहाँ पे हमारा बी एंड डी दोनों एक साथ, ठीक है। यहाँ पे हमारा सी हो गया, नीचे है हमारा एच और ई एंड जी एक साथ, हमारा एफ आ गया। अब हमें ए और बी के बीच में एक आर, ए और एच के बीच में एक आर है, ठीक है। ए और डी के बीच में एक आर है, ठीक है। बी और सी के बीच में, डी और सी के बीच में, नीचे भी सेम, यहाँ पे एक सिमिलर, एच और ई जी के बीच में, और ई जी और एफ के बीच में भी सेम, और सी और एफ के बीच में, ठीक है। ये हमारे सारे 2 ओम के हैं, 2 ओम्स। तो हम सिंप्लीफाई कर लेंगे इसको, हर एक हर एक पेयर को, ये वाला पेयर एंड दिस वन। सो हमारे पास क्या आ जाएगा कि ये हो गया अपना ए, ये हो गया बी, ये हो गया सी, ये हो गया अपना एच, ये हो गया ई जी, ये हो गया F। तो ये बन गया हमारा 1 ओम, ये हो गया 2, ये हो गया 1, ये भी हो गया 1, ये हो गया हमारा 2, ये हो गया हमारा 1। हमें निकालना है पोटेंशियल बिटवीन ई एंड एफ, राइट। हमें रेजिस्टेंस पता है कि यहाँ पे ई और एफ के बीच में जो रेजिस्टेंस है वो है 2 ओम्स, राइट। बट हमें करंट चाहिए कि इस ब्रांच पे कितना करंट जा रहा है यहाँ पे, आई। उसके लिए हमें चाहिए क्या कि यहाँ पे कितना करंट जा रहा है बिटवीन दिस ब्रांच। बट हम यहाँ पे देख सकते हैं कि 2 एंड 1 आर इन सीरीज, यहाँ पे भी 1 और 2 सीरीज में है, ठीक है। फिर हम इन दोनों को रिप्लेस कर सकते हैं ऐसे, 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 ठीक है। ये हो गया 3, ये भी हो गया 3, ठीक। हमारा सर्किट का बैटरी जो है वो है यहाँ पे और यहाँ पे, ठीक। तो हमारा टोटल कितना आ जाएगा, ए और सी के बीच में अपर ब्रांच पे 2 ओम है, 2 ओम। यहाँ पे क्या है, यहाँ पे है 3 और 3, ठीक है, 6 ओम। 2 और 6 इन पैरेलल, 2 into 6/2 + 6, right, that is 3/2 ओम, ठीक है। तो फिर करंट कितना आ जाएगा, टोटल करंट आई, आई आ जाएगा अपना 6 वोल्ट, V by R, R is 3/2, right, this is 4 एम्पियर। सो अपना टोटल जो करंट है जो कि यहाँ पे आएगा बैटरी के थ्रू, वो हो गया अपना 4 एम्पियर, ठीक है। हमें चाहिए कि यहाँ पे कितना करंट आ रहा है जो कि है यहाँ पे the current across this branch, we need the current across this branch. So for this what we can do is we can find the current across this whole branch, this branch, ठीक है। ये कितना होगा, I is V times R, right? So I is proportional to R since V is constant. और we can just see कि यहाँ पे 6 वोल्ट है ना A और C के अक्रॉस में, A और C के अक्रॉस 6 वोल्ट है। तो ये जो पाथ है, ये वाला जो पाथ है, टोटल पाथ येलो में जो पाथ है, उसके अक्रॉस भी 6 वोल्ट ही आएगा। ठीक है, तो करंट कितना आ जाएगा, 6 वोल्ट बाई 6 ओम, जो कि हो गया 1 एम्पियर। ठीक है, तो फिर हमारा पोटेंशियल कितना आ गया, वी ई एफ जो हमें पूछा है, हो गया आई इंटू आर। आई है ये, आर हमें पता है कि 2, मतलब हमारा वोल्टेज आ गया 2 वोल्ट। ठीक, सो our answer will be 2 volts. Okay, and that was all for today. कुछ प्रॉब्लम्स में थोड़ी दिक्कत आई, बट आई थिंक यू वुड हैव बेनिफिटेड बाय लर्निंग कैसे प्रॉब्लम्स को अप्रोच करनी है। आपको भी अगर एग्जाम हॉल में दिक्कत आए, आपको कैसे उसे हैंडल करना है। ठीक है, एंड प्लीज़ डोंट नेग्लेक्ट फिजिक्स। फिजिक्स आपकी रैंक लाएगी। आप कौन से कॉलेज में 5 साल गुजारेंगे, दैट विल बी डिसाइडेड हियर। And keep studying, keep practicing, and have a nice day. Bye then. See you in the next video. And you guys can comment below आपको और कौन से टॉपिक पे वीडियोस चाहिए. And if you like the video, you can share it with your friends. Bye guys. Have a nice day.